Hello friends, welcome to Secret of Electronics. In this video, we will learn how to make a electric shock-free automatic water pump controller for a water tank. In this automatic water pump controller, we do not need to put any wires in the water tank, so it will be a electric shock-free automatic water pump controller. The circuit diagram consists of two main sections, the microcontroller section and the relay driver with a AC 220 volt pump circuit. The microcontroller section features a Attiny85 microcontroller, which is responsible for controlling the water pump based on water level measurements. It interfaces with a SCSR04 ultrasonic sensor, which has four connections: BCC for power, GND for ground, trigger for sending ultrasonic pulses, and echo for receiving the reflected signal. The microcontroller calculates the water level by measuring the time taken for the pulse to return. Based on this information, the Attiny85 controls the relay connected to PV1, deciding when to turn the water pump on or off. The relay driver and AC pump circuit work as a actuator to control the pump. A BC547 transistor is used as a switch to drive the relay, with a 5 kilo ohm resistor acting as a current limiting resistor to the transistor's base. When the Attiny85 outputs a high signal to the relay pin, then the transistor conducts, activating the 5-volt relay. This relay is used to switch the 220 volt AC water pump on or off, allowing for automatic water level control. A 1N4007 diode is placed across the relay coil to protect the circuit from voltage spikes generated by the relay's inductive load. The AC 220 volt input is connected through J2 and the pump is connected by J3, ensuring safe operation of the high voltage system. This design ensures a electric shock-free and reliable automatic water pump controller without requiring any direct wiring inside the water tank. The given Arduino code is designed to control a automatic water pump system using a Attiny85 microcontroller and a SCSR04 ultrasonic sensor to measure the water level in a tank. The code defines three main pins: trig_pin PV3 to trigger the ultrasonic sensor, echo_pin PV4 to receive the reflected signal, and relay_pin PV1 to control the relay that switches the water pump on or off. The system operates based on two predefined threshold levels: tank_immediate_level 6 cm, which indicates a low water level requiring the pump to turn on, and tank_full_level 1 cm, which signals a full tank turning the pump off. In the setup function, the trig_pin is configured as a output, the echo_pin as a input, and the relay_pin as a output to control the pump. Initially, the relay pin is set to low, ensuring that the pump starts in a off state. The measure distance function is responsible for measuring the water level using the ultrasonic sensor. It first sends a short low pulse 2 microseconds to the trigger_pin, followed by a high pulse for 10 microseconds. The ultrasonic sensor emits a sound wave, and the pulse-in function measures the time taken for the wave to reflect back to the sensor. The time duration is then converted into distance in centimeter using the formula distance equal to duration multiplied by 0.034 divided by 2, where 0.034 centimeter per microsecond is the speed of the sound in air. In the loop function, the measured water level is continuously checked. If the water level is greater than the tank_immediate_level 6 cm, meaning the tank is running low, the relay pin is set high, turning on the pump to refill the tank. Conversely, if the water level is less than or equal to the tank_full_level 1 cm, meaning the tank is full, then the relay pin is set to low, turning off the pump to prevent overflow. A 100 millisecond delay at the end of each loop cycle provides stability and prevents rapid switching. This setup ensures a automatic and efficient bottle level management system without requiring any direct electrical connection inside the tank. Now we will use the Arduino Nano board as a ISP programmer to upload the program to the Attiny85 microcontroller. If you do not know how to program the Attiny85 using a Arduino Nano board, you can watch our tutorial on how to program the Attiny85 microcontroller using a Arduino Nano board by clicking the I button. Now take a Arduino Nano board with the Arduino ISP program uploaded and connect the SPI pins of the Attiny85 microcontroller to the SPI pins of the Arduino Nano board according to the circuit diagram displayed on the screen. After making the connections, connect the Arduino Nano board to the PC using a USB cable. Once connected, open the Arduino IDE and load the code file, which you can download from the link provided in the description. After loading the code file, select all the required settings under the Tools menu. Once all the settings are selected, upload the code to the Attiny85 by clicking the Upload button in the Arduino IDE. Now connect all the components according to the main circuit diagram, which we discussed at the beginning of this tutorial. I am using a AC 220 volt lamp in place of the bottle pump because the bottle pump is not available. As you can see, the lamp is initially on because the bottle glass is embedded. This means that if the bottle tank is initially embedded, then the bottle pump will turn on. Now as I fill the bottle glass, you can see that when the bottle level reaches the top of the glass, then the lamp turns off automatically. This indicates that the bottle pump will also turn off automatically. Now as I lower the bottle level in the bottle glass, you can see that when the bottle level in the bottle tank reaches the embedded tank level, then the lamp turns on automatically. This means the bottle pump will also turn on automatically and will remain on until the bottle level in the bottle tank reaches the tank full level. If you liked this video, do not forget to subscribe to our YouTube channel to watch our upcoming interesting tutorials.